Now, Daphne López is going to conclude this session. You have to pay attention because she speaks so fast, so don't miss a thing about soil need complementarity as a responsible of small-scale over-yielding in mixed pine forest. Thank you.
¿Esto se puede bajar? No pido poco. Okay. That I'm going is here, fine? Okay. That I'm going to show you is a little bit of my PhD thesis that I just presented in October, and this PhD thesis was focused in increasing the knowledge of the dynamics. Of the dynamics of the mixed versus monospecific forest of Pinus sylvestris and Pinus pinaster in the context of the supply of the ecosystem service. And the first question that we could wonder could be, okay, and why analyze the ecosystem service in the mixed stance? And the answer could be that exists a growing evidence that the mixed stance could be more efficient supplying ecosystem service than monospecific stance. And the second question could be, okay, and why analyze concretely this type of mixed stance, the Scots pine and maritime pine mixed stance? And the answer could be that both Pinus species, Pinus sylvestris and Pinus pinaster, is two of the main forest species in the Iberian Peninsula, but also the admixture of both Pinus species suppose around of the 35% of the Spanish conifer mixed pine forest. Okay, now we just know to the admixture of Scots pine and maritime pine could be more efficient than the monospecific stance supply and ecosystem service, but which type of ecosystem service we analyze in this part of my PhD thesis? Okay, here we analyze the production, the overstory production. So we want to test if exists a positive relationship between biodiversity and productivity, as just demonstrated in many other types of ecosystems. And other authors point that the most responsible of this positive relationship between biodiversity and productivity could be the niche complementarity. And for that, we also want to analyze another ecosystem service as soil fertility. And in this point, I should to comment also that, yes, this biodiversity productivity positive relationship is demonstrated, but is only demonstrated at a small scale. For that, the aims of this part of my PhD thesis was, one, to test the influence of the spatial approach to detect this overstory yield, but also to understand the mechanism involved determining this overstory yield. Okay. To achieve these objectives, we apply a triplet sampling design, and it means we select 18 different plots divided in 6 different triplets, located, as you could see in the picture below. And which is a triplet? A triplet consists in 3 different stance types. One monospecific stance of Pinus sylvestris, one monospecific stance of Pinus pinaster, and one mixed stance of both Pinus species. And the condition to be included in a triplet is these plots must be located less than 1 kilometer from each other, but also it have to have a similar condition of age, density, silviculture, in order to could realize a parkway comparison between mixed versus monospecific stance. Which variables we analyze in each plot? Okay, in each plot, in this part of my PhD thesis, we analyze the soil in order to test this soil fertility, but also the overstory in order to test this overstory production. Okay, when we analyze the soil, we analyze in each plot 1 pit soil of at least 15 centimeters depth, and we analyze the water and the fertility analyzing in order to analyze the water, the useful water of the well profile from 0 to 15 centimeters depth. But to analyze to the fertility, we analyze the sum of actionable cations, again from 0 to 15 centimeters depth. And when we want to analyze the overstory, we want to test the effect of the scale, but also the effect of the spatial distribution pattern. When we want to test the effect of the scale, we analyze the trees in 2 different scales. At the stand levels, it means the size of the inventory is the total plot. We measure all the trees. And when we want to looking for this mixture effect of this more intimate mixture, we try or we need to decrease this scale of the study. For that, we analyze at a small scale or at neighborhood scale, analyzing 10 inventories per plot of 4 meters radio. And when we don't want to test the spatial distribution pattern, we measure different distance among the trees in 2 different ways. One, attending that we have trees independent of the species that they belong in, but also attending that we have trees of different species, and it could condition that the distribution pattern. Okay. Here you have a few summary of the data of the analysis, of the statistical analysis applied to each data set. And I'm going to pass to the result, but because I think it's more interesting. Okay, when we analyze this overstory, trying to looking for this over-yielding mixed stand, we analyze the 3 different stands type at 2 different scale levels. And we found that just exists this overstory over-yielding in mixed stand. If we, if you, if you could see here, the mixed stand had higher density than the monospecific stands, and as you could see here, the total basal area of the mixed stand is higher, at least of one type of the monospecific stand, the Scott spine monospecific stand. But if you could realize that this over-yielding is only detected at a small scale, not at bigger scale. And why? Okay, the answer could be the mixture spatial pattern is conditioned by the scale. It means if you have a mixture effect, but this effect is now too strong, maybe this effect is dissolved, because maybe this effect could be masked by other effects as climate effect or management effect, and this mixture effect is dissolved at a bigger scale. But when we try to looking for this mixture effect and we go only to looking for the contact zone of the trees, maybe we could find this mixture effect. Okay. But we didn't want to stop here. We want to go deeper to analyzing what is the reasons to this over-yielding in mixed stands. And for that, we analyze the distribution pattern, as I said before, in 2 different ways. Attending that we have trees independent of the species that they belong in, and attending that we have a species, 2 different species. Okay. When we analyze the distribution pattern of the trees in the 3 different stands types, we think that we saw that the trees are distributed as random pattern. Okay. But what happens when we analyze this, attending that we have trees of different species? Okay, we found that the Pinus sylvestris in the monospecific stands of Pinus sylvestris are random distributed. Pinus pinaster in the monospecific stands of Pinus pinaster are random distributed. But what happens when they cohabit? That happens that they change the distribution pattern, and they change to be located at random distributed to regular distribution. And this is really interesting, but the regular distribution is the distribution pattern that supports more production. You must realize that is the distribution pattern used by the industry to optimize the production. But again, we want to stop here. We didn't want to stop here. We want to go deeper to the analysis. And for that, we analyze the distance between the different trees, again, attending that we have trees or we have trees of different species. And we found that the distance between the trees in the mixed stands is shorter than in the monospecific stands. But why, of which species belonging these trees that it is shorter or nearest in the mixed stands? That we found that this tree that is nearest in the mixed stands belonging to different species. It means the 3 different species display a mutual attraction, or the individuals of the different species grow closer, and this is just before described by other authors. It means the result of this is the trees of different species when grow together could to be more efficient or to apply more efficient exploration of the grow space. It means in the same space, fit more trees. It means we have more production. Okay, we just to notate that exists a biodiversity productivity positive relationship. And as I said before, we didn't stop here, and we want to deeper in this analysis, and we want to test if exists this niche complementarity. And for that, we analyze how responds both pinus species to different soil variables, and we analyze the niche amplitude of both pinus species to do different variables, the soil moisture and the soil fertility, in order to try to build a bidimensional niche model. And yes, we found that exists a complementarity in the use of the resource. It means both pinus species use the resource in an opposite trend. Pinus sylvestris is located in a place with more wet and more fertile places, and Pinus spinaster are located in a less wet and less fertile places. So, yes, exists a complementarity use of the resources, and we think that this is related with a higher efficiency in the space use in the mixed stand. For that, the conclusion of this part of my PhD thesis could be that an overstory yielding in the mixed stand was caused by the more efficient in-space use, caused at the same time by the water and fertility soil niche complementarity, but also this mixed stand overstory yielding was only detected at a small scale thanks to the more intimate species mixture at this level. Only to finish, I want to leave you a recommendation or a reflection that maybe we try to learn to the trees to take only that we need and leave the rest in order to be more sustainable but also more efficient according to the sustainable development goals of the United Nations for 2030. No more. Thanks for your attention.